Welcome to our deep dive into AI. Today, we're going to explore multimodal AI, like how we experience the world, not just through one sense, but sight, sound, even touch or smell sometimes, all together. That's what multimodal AI is aiming for, giving machines that same ability to process all sorts of data at once.
Exactly. We've got this collection of sources here, really fascinating stuff. And what we're trying to do is unpack it all for you. What exactly is multimodal AI? How does it actually work? Why is it such a big deal? And then where is it all going? We'll look at the techniques, the applications, the stuff that's relevant for tech folks like yourselves, even some of the challenges that are still out there.
So, a real sensory revolution in AI. Let's start with the basics. What is multimodal AI at its heart?
Well, it's AI that can process and understand multiple types of data at the same time. We call these modalities. Like you could have an AI looking at a picture, listening to audio, and reading text all at once, and it would understand how those all connect.
That's pretty different from what we've seen with AI so far.
Oh yeah, it's a major shift. Traditional AI, unimodal, it just focuses on one type of data. You've got your language AI, your image AI, but they work in isolation. Multimodal AI smashes those walls down, gets them working together.
Kind of like how we experience the world, right?
Absolutely. I mean, think about it. Our brains are constantly integrating all this information from our senses. We're seeing, our hearing, feelings all at once to give us a complete picture. Multimodal AI is trying to do the same thing for machines. Like when you're talking to someone, you don't just hear the words, do you?
Right, there's the tone of voice, the facial expressions, the whole thing.
Exactly. It's all those things combined that give you the real understanding. And that's what multimodal AI is about. It's about looking at the whole picture, not just isolated pieces.
And I guess that's where the power lies, the whole being greater than the sum of its parts.
Precisely. When AI can fuse data from all those different modalities, you get a much richer, deeper understanding of complex situations. Like imagine an AI that can see a photo and read the caption at the same time. It's not just about the image, and it's not just about the words, it's about how they connect and enrich each other.
Okay, you've mentioned modalities a bunch of times now. Can we break that down? What exactly are modalities in the context of AI?
Sure, a modality in AI, it's just a type of data, a sensory input that the system can handle. The most obvious examples are text, images, audio, and video. Those are the big ones.
But there's more, right? It's not just limited to those four.
Oh yeah, way more. It could be data from sensors, like LiDAR for self-driving cars or GPS, or even things like body language, facial expressions, or even biometric data like heart rate. The range is pretty huge.
Wow, so much data to deal with. Is there like a common thread that runs through all these different modalities?
Well, the main thing is that they're all really different. We call that heterogeneity. Each modality has its own structure, its own way of representing information, like a written paragraph versus a photograph. They could be describing the same thing, but the way they describe it is completely different. One is all words, the other is pixels and colors.
Like apples and oranges. Same basic concept, fruit, but totally different forms.
Exactly. And the interesting thing is, even though they're different, there are often connections between them. And when AI can tap into those connections, when it can combine them effectively, that's when it gets really powerful. One modality might fill in gaps in another or provide context that's missing.
So we've got all these different data streams. How does AI actually combine them in a way that makes sense? It sounds kind of tricky.
That's where information fusion comes in. This is how multimodal AI actually puts all those pieces together to get more accurate, more reliable insights. And you're right, it's not simple. There are different approaches to this depending on what you're trying to achieve and what kind of data you have.
Can you walk us through some of the main approaches? How does AI go about fusing information from different modalities?
Okay, so one way is called early fusion. It's like mixing all your ingredients together right at the start of a recipe. You're combining the raw data, or very basic features, from each modality early on in the process.
Makes sense. So you're catching those connections right away.
Right, the idea is to capture those low-level correlations, but it can get tricky when the modalities are very different, like trying to combine raw pixels from an image with, say, sound waves from audio. They just don't naturally fit together.
You'd need to find some common ground first. So what's the opposite of early fusion?
That would be late fusion. It's more like cooking each ingredient separately and plating them together at the end. Each modality gets processed independently, and then you combine the final results like the predictions or the high-level features.
So it's more modular. You can focus on each modality individually.
Yeah, and it's good for modalities that are very different from each other. But you might miss out on some of the early interactions between them if you wait until the very end to combine them.
So it's a trade-off. Early fusion catches those early connections, but late fusion keeps things cleaner.
Exactly. And then there's intermediate fusion. This is kind of the middle ground where you combine modalities at different stages throughout the process. You try to capture some of the early interaction while still allowing each modality to be processed in a way that makes sense.
Okay, so it's a balancing act. And do researchers ever use a mix of all these approaches?
Absolutely. Sometimes they use hybrid fusion, which just means combining different strategies within the same system. That gives you the most flexibility.
So it's a very dynamic process. What are some of the tools that make this kind of fusion possible? How do they actually get it to work?
Well, we've got things like specialized neural networks, like CNNs for images, transformers for text. And these are being adapted for other modalities too, like audio and video. There's also this concept of joint embedding spaces, where the AI learns to map data from different modalities into a common representation.
So it's finding a shared language for all these different data types.
Exactly. And then there are attention mechanisms, especially cross-modal attention. This allows the AI to focus on the most relevant parts of one modality while looking at another. It's like highlighting the connections between them.
Kind of like when you're reading a book and you see a picture that goes with it, you're focusing on both the words and the image and how they relate.
That's a great analogy. It's that same idea of focusing and connecting. Now, all this raises a question. How does the AI actually learn these connections? How does it know that a particular word and a particular image are related?
Yeah, that's a good question. It can't just be random, right? There has to be a method to the madness.
That's where cross-modal alignment comes in. This is all about teaching the AI to understand those relationships between different modalities. We're talking about finding shared meaning even when the data is in completely different formats.
And it's like building a bridge between those different worlds of data.
Exactly. The goal is to create these shared structures, embeddings, where data that represents the same concept, even if it's from different modalities, ends up close together. Like if the AI sees a picture of a dog and hears the word dog, those representations should be near each other in its understanding.
And this alignment, it's not just a nice to have, right? It's crucial for the whole system to work.
It's absolutely essential. Without it, the AI wouldn't be able to understand how things connect. It wouldn't know that a spoken command relates to a specific object it sees, or that a certain piece of music evokes an emotion that's described in a text. It would just be processing all this data without really understanding it.
Okay, so how do they actually teach AI to make those cross-modal connections? Are there like specific training methods for this?
There are a few key techniques. One really powerful one is contrastive learning. You basically train the model by showing it pairs of data. Some pairs are related, like an image and its correct caption, and some pairs are unrelated, like an image and a random caption. And the model learns to tell the difference.
So it's learning by comparing and contrasting.
Exactly. And in doing so, it starts to figure out that, okay, these two things belong together and these two things don't. And it starts to organize its understanding based on that.
It's a very intuitive way to learn. What other techniques are used for this alignment?
Attention mechanisms are super important too. We talked about these before, but they allow the AI to focus on the important parts of one modality when it's looking at another. Like imagine you're looking at a picture of a cat sitting on a mat, and there's a caption that says, "The cat is fluffy." The attention mechanism will help the AI focus on the cat's fur in the image while processing the word fluffy.
So it's learning to connect the visual details with the descriptive words. Cool. So with all this incredible technology being developed, where are we actually seeing multimodal AI in action right now? Where is it being applied?
Oh, it's already making a big impact in a bunch of different areas. In healthcare, imagine an AI that can look at medical images like X-rays and MRIs, and combine that with the patient's records, their doctor's notes, even genetic data. You could get much more accurate diagnoses and personalized treatments.
Wow, that's life-changing stuff. What about other fields?
Education's another big one. Multimodal AI can personalize learning. Imagine AI that not only looks at what a student is reading or watching, but also analyzes their facial expressions, their interactions. It could figure out if they're engaged, if they're understanding, and adapt the learning experience to fit their needs.
That could be game-changing for education. What about something a bit more fun?
Definitely. Think about entertainment, especially games. Multimodal AI is creating much more realistic, responsive characters. Characters that react not just to what you type, but also to what you say, your body language, even your emotions.
That's amazing. It's like they're actually understanding you on a deeper level.
Right, and it's not just games. It's being used behind the scenes to improve content creation and media search as well. But moving on to something more practical, think about robotics.
Okay, how is multimodal AI changing things there?
It's making robots much better at interacting with people and the environment. Imagine a robot that can combine data from cameras, microphones, even touch sensors to get a much richer understanding of what's going on around it. This could lead to safer human-robot collaborations, robots that can do more complex tasks, maybe even robots with electronic noses that can detect hazardous materials, or even judge the quality of food by smell.
Robot chefs, here we come. But seriously, that's pretty incredible.
And of course, we can't forget autonomous vehicles.
Yeah, that seems like the poster child for multimodal AI.
It is. These vehicles need to constantly process data from cameras, LiDAR, radar, all kinds of sensors. They need to understand what's happening all around them to navigate safely.
So each sensor is like a different sense, and they all work together to give the vehicle a complete picture of the road.
Precisely. And even in something as simple as e-commerce, multimodal AI is making a difference. It's improving product recommendations and search. Like if you search for a stylish summer dress, the AI can consider both the words and the images to give you better results.
So no more endless scrolling trying to find the right thing. That's a huge win.
Right? It's all about making things smarter and more user-friendly. But it's not all smooth sailing. There are still some big challenges in multimodal AI.
Like what? What are some of the hurdles that researchers are still trying to overcome?
Well, one of the biggest is data integration and alignment. We talked about how different these modalities are, and getting them to work together seamlessly is still a huge challenge. Like syncing up the visuals in a video with the words in a transcript, making sure actions and speech are correctly aligned in time. That's not easy.
So it's a really complex synchronization problem. What else is on the list?
Computational complexity is another big one. These models require a lot of processing power and memory. Training them takes a long time, and even running them can be demanding.
So you need some serious hardware to make this all work.
You do. And then there's the issue of real-world data being messy. It's noisy, it's incomplete, images can be blurry, audio can have interference, and sometimes data might be missing entirely. Multimodal AI needs to be robust enough to deal with all that.
That's a tough one. And once we've built a system, how do you make sure it works in the real world?
Yeah, that's another challenge. It's called generalization and deployment. A model might work great in the lab, but then struggle when it's out in the real world, dealing with different environments, different devices. Getting it to work reliably across the board is an ongoing effort.
So there's still a lot of work to do, but what about the future? What are some of the exciting developments on the horizon?
Oh, there's so much happening. We're seeing the emergence of unified models, new architectures like GPT-4o and Gemini that are designed to handle multiple modalities within a single framework. This could be a big step toward AI that understands and even creates content in all sorts of forms, seamlessly.
Wow, so AI that can write, draw, compose music all in one.
That's the idea. We're also seeing big improvements in cross-modal interactions. Attention mechanisms are getting better, leading to more sophisticated fusion and alignment, AI that can grasp the subtle relationships between different modalities.
That's really exciting. Any other trends you're seeing?
Real-time multimodal processing is becoming increasingly important, especially for things like self-driving cars and augmented reality. The AI needs to analyze data from multiple sensors on the fly and react instantly.
So fast-thinking AI. What else?
We're also seeing really cool techniques for multimodal data augmentation, which means creating synthetic data to help train these models, like generating images from text descriptions. This can help when you don't have enough real-world data to train on.
So it's like artificially expanding the training data set. Pretty clicker.
And then, of course, there's the huge benefit of open-source collaboration. Platforms like Hugging Face are making tools and resources available to everyone, which is really accelerating progress.
That open source spirit is so crucial for AI development.
And last but not least, we're seeing the development of totally new techniques for alignment, like Align Mamba, which uses something called optimal transport to create even better cross-modal understanding. It's all about pushing the boundaries of how well AI can connect those dots between different types of information.
Align Mama, optimal transport? That sounds pretty complex.
It is, but it's all part of this amazing evolution we're seeing in AI.
So let's wrap up here. What are some of the key takeaways you want our listeners to walk away with?
Well, the big thing is that multimodal AI is about more than just processing multiple data types. It's about creating systems that perceive the world in a more holistic, human-like way. It's about bringing those different senses together to achieve a deeper, richer understanding.
And while there are still challenges like data integration, computational power, and real-world deployment, the advancements are happening at an incredible pace, especially with these unified models and real-time processing capabilities.
Exactly. And just imagine what's possible when AI can truly comprehend complex situations by combining all those senses, not just words, but tone of voice, facial expressions, visual cues, environmental data. What kind of amazing human-computer interactions could we have then?
It's mind-blowing to think about the potential. So if you're interested in learning more about multimodal AI, we encourage you to check out the papers and resources we mentioned. There's a whole world of fascinating stuff out there to explore. What aspects of multimodal AI stand out to you? What applications excite you the most? And what are some of the challenges that you think are most important to address?
We'd love to hear your thoughts.
Thank you so much for joining us today. We hope this has been an informative and engaging deep dive into the world of multimodal AI.